Geometry review sheet number 2. More angles, exteriors, and ratios. Here we go. Question number 1. In the diagram below, X, G, and EN intersect at A. More importantly, AM is perpendicular to XG, and the measure of angle GAN is equal to 20 degrees. Well, one thing that's extremely important to remember here is that this is the sign for perpendicular. And perpendicular means that you have two lines that meet to form right angles. Well, if that's true, if AM is meeting XG to form a right angle, I could see that they put a little box there on one side, but it also means that on this other side, I'm going to make it a little bit bigger, that's also a 90-degree angle. And that's important to remember as we kind of put in all of the angles where they belong before we even try to answer the ultimate question. Well, if the measure of GAN is 20 degrees, then the angle on its opposite side over here is also going to be 20 degrees because vertical angles are congruent. And if XAE and EAM together make a right angle, that means that they are complementary, that they add to 90 degrees, which means that 90 minus 20 is 70 degrees right there. And of course, this right angle on the other side means that that is 90 degrees. And underneath line XAG, we have a 20-degree angle, which means that angle XAN is its linear pair, which means it's also supplementary, which means this is going to be 160 degrees. Another important part of this problem is being able to read the angle that they're asking for. It says find the measure of angle MAN. So I could outline M to A to N, which means that we're trying to find this whole entire angle over here. We have to remember that an angle is the sum of its parts, and the two parts of that angle is a 90-degree and a 20-degree angle. So 90 plus 20 is 110. So the measure of angle MAN is equal to 110 degrees. Question 2. In the accompanying diagram, line AOB is a straight line. The measure of angle AOC is 5x. The measure of angle COD is 3x plus 30. And the measure of angle DOB is 2x plus 10. Find the value of x. Well, here the most important thing to remember is that the angles, the consecutive adjacent angles that are on a line will always add to 180 degrees. We need to remember that a line always is as if you have half of a circle, which is 180 total degrees. So all the consecutive adjacent angles on a line will always sum to 180. So therefore, quite simply, we can just add them all up. 5x plus 3x plus 30 plus 2x plus 10 and set it equal to 180 degrees. 5x plus 3x plus 2x is 10x. 30 plus 10 is 40 is equal to 180 degrees. 10x is equal to 180 minus 40. 10x is equal to 140. Divide by 10. X is equal to 14. Go back, read the question. They're asking for x, so we are done with the problem. If they needed any of those angles, we could have easily substituted the 14 in to find out exactly what each one was. Question 3, in the accompanying diagram, line AB and CD intersect at point E. If the measure of angle AEC is 3x plus 12, and the measure of angle DEB is x plus 24, find the value of x. Well, here we should never forget that when you have any two intersecting lines, you're going to have vertical angles, which are congruent, vertical angles, which are congruent, or you're going to have two linear pairs, which are supplementary. So you can have one of the two instances. Well, here clearly we have vertical angles, which are congruent. Therefore, we could just set them equal to each other. 3x plus 12 is equal to x plus 24. 3x minus x is equal to 24 minus 12. 2x is equal to 12. Divide both sides by 2. X is equal to 6. That's the question, so I am finished. 4, I intentionally put on the review to demonstrate the importance of reading through the given. In the accompanying diagram, angle 1 and 2 are supplementary. That's very important to remember. What is the measure of angle 3? Well, in this problem, we're going to start out right there at angle 1. And just to, looking at angle 1 visually, we see, well, angle 1 and that 35-degree angle are clearly linear pairs and therefore supplementary. So we could, just start out with 180 minus 35 to figure out that the measure of angle 1 has to be 145. 145. Well, if the measure of angle 2 is a supplement of angle 1, well, so is this 35-degree angle over here, which means the measure of angle 2 would be 35 degrees because it states right here in the given, angle 1 and angle 2 are supplementary. And then we can also then see that angle 2 and angle 3 are vertical angles, and vertical angles are congruent. So this is also going to be 35 degrees. So the measure of angle 3 will be equal to 35 degrees. In the accompanying diagram, the adjacent angles formed by intersecting lines AB and CD have the measures of 3x plus 50 and x plus 10, respectively. Find x. Well, here's a very similar problem as we had 2 questions earlier, but now we're looking at the 2 angles that are adjacent on the line. And I'm hoping that many of you would see that this is clearly, the x plus 10 is an acute angle, and that the 3x plus 50 is an obtuse angle. They're together on a line, they're linear pairs, and therefore they are supplementary. And when 2 angles are supplementary, we add them up. 3x plus 50 plus x plus 10, and we set it equal to 180 degrees. We get 4x plus 60 is equal to 180. You get 4x is equal to 180 minus 60. 4x is equal to 120. Divide by 4, and x is equal to 30. The question is find x. We found x. We are golden. Lines AB and CD intersect at E. The measure of angle AED is 110 degrees. The measure of angle DEB is 3x plus 2y. The measure of angle BEC is 9x plus y. And the measure of angle CEA is 70 degrees. Find the values of x and y. Check your answers. Only an algebraic solution will be accepted. All right. Well, this one, as I told most of you already, is one that demonstrates our ability to solve simultaneous equations. Well, there are many true equations we could start this out as, but I'm going to take the most straightforward one, which is the vertical angles are congruent. So if vertical angles are congruent, that would mean that my 3x plus 2y angle would be equal to 70 degrees. Vertical angles are congruent. And it would also mean that my 9x plus y would be equal to 110 degrees. Now, there are many ways we can solve a systems of equations. A lot of you use elimination method. Some of you use substitution method. This all comes from algebra last year, and I would hope that you would just use the method that you're most comfortable with. I'm not going to change anybody's technique as long as we're getting the right answer. So I'm going to decide to eliminate the y's. Whenever I see that one of my variables has a 1 as a coefficient, like the positive y, I find that the easiest one to change in most situations. So I'm going to put that entire equation in parentheses and change my positive y to a -2 by multiplying the equation by -2. Now, what makes that fair is that I'm going to distribute that -2 throughout the whole entire equation. So -2 times 9x is -18x. -2 times y is -2y. And -2 times positive 110 is going to be -220. I'm now just going to put like a line through that middle one because I don't need it at the moment. And I'm now going to take the top equation and add it to the bottom modified equation. And I get a positive 3x plus a -18x, which is -15x. My two y's cancel out and is equal to 70 minus 200 or plus a -220, which will be -150 divided by -15 on both sides. And that would give me x is equal to 10. Well, once you have one variable, you can substitute that x into any of the other equations that you have in order to solve for y. So I'll take the top one. That looks pretty simple. So I'm going to substitute into my 3x plus 2y equals 70. So my 3x is now 10 plus 2y is equal to 70. 3 times 10 is 30 plus 2y is equal to 70. 2y is equal to 70. I'm going to bring the 30 to the other side and subtract it. 2y is equal to 40. Divide both sides by 2. And my y is equal to 20. Now, in this problem, it not only said to solve, but also to check your answers. So I'm going to take my 3x plus 2y, right here, you see it in my 3x plus 2y degrees, and see if indeed that is equal to 70. Well, that means I'm going to take my 3 and multiply it by my x, which is 10. And I'm going to add it to 2 times my y, which is 20. 3 times 10 is 30, plus 2 times 20 is 40. And sure enough, that equals 70 degrees, like we have right there. So that's one check. And let's check the other one. So we got 9x plus y, which is supposed to be equal to 110 degrees. So it's 9 times 10 plus 20, which is 90 plus 20, which is equal to 110. Check. In the company diagram, angle ACD is an exterior angle of triangle ABC. The measure of angle A is 3x. The measure of angle ACD is equal to 5x. And the measure of angle B is 50 degrees. Now, I just want to jump right now onto, say, our to Google Classroom, and to show you that we have these different PDFs that I put on. One was about the exterior angles right here. So I recommend that everybody read through these notes. They're very, very, very helpful. But the one I want everyone to look at is this one right here. This theorem on the first page. It says the measure of an exterior angle of a triangle is equal to the sum of the measure of the two non-adjacent interior angles. Non-adjacent interior angles may also be referred to, as Mr. Frank often uses, remote interior angles. So you can see in that picture, you can see the 100-degree angle is the exterior angle, and the two non-adjacent, the remote angles, are 40 and 60, and obviously 40 plus 60 is equal to 100. So going back to our problem, this is a problem where you must use that. There isn't any alternative method here because we have representatives rather than numbers for our angles. Here the exterior angle, angle ACD, is 5x, and the two remote angles are 3x and 50. Well, the exterior angle will always be equal to the sum of the other two interior remote angles. So that leads to a fairly simple equation. 5x, bring over the 3x, it's equal to 50. 2x is equal to, 50, divide by 2, and x is equal to 25. The question is find x. It's a multiple choice question right there. But slightly more complicated, I know, will be a problem where you need to create your own picture. So here they're saying in triangle ABC, AC is extended through C2D. I'm going to stop right there before I continue. I'm going to make a quick triangle. Usually when we're drawing, we put the exterior angle kind of over here. This is very common, which means that if side AC is extended through C, this would have to have been my A. There's my C. There's the side that's extended through C to D, which means this vertex up here must be B. And now I could continue. The measure of angle BAC is 6x plus 10. Well, BAC, A being the vertex, B from B to A, is this angle over here. There's my 6x plus 10. The measure of angle ABC up here is going to be 6x minus 10. No, it's hard to write so small here. And then my exterior angle BCD is 8x plus 20. But once we get to this spot, it's really not that different from the previous question. The exterior angle will always be equal to the sum of the remotes. Well, here we end up with 8x plus 20 is equal to 12x. The 10s cancel each other out. I'm going to bring the 8x to the other side and kind of work backwards here. 20 is equal to 12x minus 8x. 20 is equal to 4x. Divide by 4 and get x is equal to 5. I'm reading that backwards, so I'm going to just turn it around. X is equal to 5. And finding x was the question. Nice and simple. Okay, a ratio problem. Well, ratio problems are done in a variety of ways. However, I like to always make a table. In an isosceles triangle, the ratio of the measure of the vertex angle to the measure of the base angle is 1 to 4. Find the measure of the vertex angle. Well, one thing to be very mindful of in some ratio problems is when they use the word to. That's important because you can almost substitute where it says TO with the two dots of your ratio. And the reason why that's important is because anything that's on the left side of that 2 is going to be representative of the number on the left side of the actual colon that separates your ratio. And whatever's on the other side, in this case the base angle, that means that 4 is going to be representative of the base angle. So I'm going to make a table here that starts with just my vertex and my base. And the 1 belongs to the vertex and the 4 belongs to the base. However, an isosceles triangle, like all triangles, have 3 angles. And when we're referring to the vertex and the base angles, there is 1 unique vertex and always 2 base angles. If I could just jump back to the Google Classroom for a second and go back here and click on the isosceles triangle PDF. There's some very good information here. But this theorem right here is the one that we're going to be using. If two sides of a triangle are congruent, the angles opposite them are congruent. Or if you know you have an isosceles triangle, you can just say the base angles of an isosceles triangle are congruent. So since we know that to be true, we can go back to this ratio problem and just say, well, hey, there's not one base angle, there are two base angles. And if they're congruent, and this one has a 4, then this one also has a 4. And like all ratio problems, once I have the numbers separated, I attach an x, because at the end of the day, as long as we multiply those numbers by the same number, x, we're going to maintain that 1-to-4 ratio. Well, the last part of most ratio problems is coming up with something that's true, an equation where we can solve for x. Well, the thing that's true about all the interior angles, all three interior angles of a triangle, is that they always sum to 180 degrees. So when we add 1x plus 4x plus 4x and set it equal to 180, we obviously get 9x, which is equal to 180. We divide by 9 on both sides, we get x is equal to 20. And once you have x in a ratio problem, you could just go back and represent all your numbers. 1x means 1 times 20, which is 20 degrees. 4 times 20 would be 80 degrees, and the two base angles are the same. 80 plus 80 plus 20 does equal 180, which means I'm on a right track. What was the question? The question was find the measure of the vertex angle. The V represented my vertex angle. The vertex angle was equal to 20 degrees. Construct the median to AB in triangle ABC. Well, we need to remember that a median is a line segment from any vertex to its opposite sides midpoint. That's the key. So we really need to just find the midpoint of AB, and then the rest of it is pretty simple. Well, to find the midpoint is the same thing as bisecting. It's the same thing as finding the perpendicular bisector. It's circle A and circle B. However, when you are doing circle A and circle B, you need to make sure that you just open to more than halfway. That looks more than halfway. So I'm going to do circle B. I'm going to make the same exact size circle at A, circle A. Oh, no, I didn't just do that. Okay. And I am going to use, once again, a dotted line to represent my straight edge in connecting those 2 points of intersection. Most importantly is that we find the midpoint, which is right there. I'll label it M. Walking around the room, many people stopped right here. Don't stop here. We're not done. The actual median has yet to be drawn. The median is the line segment from the midpoint to the opposite side's vertex or vice versa. There we go. MC, that line segment right there, that is my median. Okay, so we learned about one point of concurrency thus far. And the only point of concurrency that we talked about thus far has been the centroid. So the centroid, what types of concurrent constructions are needed to find the centroid of a triangle? Well, the centroid of a triangle is the intersection of the lines drawn to the midpoint of each side of the triangle to its opposite vertex. That is right here. That is your centroid. Okay? That's the only one that we've really talked about thus far. All right. So let's make one. Construct, well, given triangle ABC, locate by construction the centroid of the triangle. Now, I am going to do the shortcut version. Why not? So here, I'm going to just just move this up here. Maybe I can make this a little bit bigger. Okay, there we go. All right. Okay, so the shortcut version would look something like this. All right. I'm going to take my compass and I'm going to look at my longest side. I'm going to use the inner right there. And I'm just going to open up, make sure my compass is open up to more than halfway to my longest side. If my compass is open up more than halfway on my longest side, I can just do 3 circles right now, all the same size. So I'm going to do circle C. I'm going to move this over and do circle B. And then I'm going to move this over and do circle A. All right. I'm going to get rid of my compass. See you later. Okay. Now, just be very, very, very careful, however, that when you begin to find these midpoints, that you're using the 2 circles of the 2 endpoints of the side you're looking for the midpoint of. Well, what does that mean? Well, here we go. So when I'm going to find the midpoint, for example, of AC, I'm going to make sure that I'm looking at the intersections of the circle A and circle C, which goes from here right down to there, right? That circle, the intersections of circle A and circle C, which means that this right here is the midpoint of AC. Now, when I'm going to find the midpoint of, say, AB, make sure I'm using circle A and circle B. That means when I'm going to find, here's circle A and there's circle B. I'm going to connect these 2 right here, right? And that means that where that straight edge intersects AB, that right there is the midpoint. Now, technically speaking, I really only need 2, but let's just do all of them. Why not? So I'm going to now find circle B and circle C. Oops, I want that to be a dotted line. And go right down there. And I'm going to mark the midpoint there. So now look, I have all of the midpoints of each side. So all I got to do now is create the medians. So I'll make the medians, I'll make them, say, red. So I'm just going to go from each midpoint, so the midpoint of AB to its opposite vertex, the midpoint of BC to my opposite vertex, and the midpoint of AC to its opposite vertex. All right, they all should be more or less intersecting at the same place, and that place, everybody, right there, that is my centroid. That's the centroid right there. Now, one thing, or a couple things that are important to remember about the centroid. Before I finish here, I'm just going to run to the front here. I took some regions questions that I just want to look at really quickly if you have some extra time. So right here, I found this on just 2 regions, June 18. So here they show you triangle SRK, question 18 on the regions, and they tell you that these are medians. Medians SC, KE, and RL intersect at M. So you need to look through this problem and know, oh, wait, those are medians. Oh, yeah, Mr. Frank taught me medians, when they all intersect in a triangle, that's the centroid. And if M right here is a centroid, there is a relationship between the 2 parts of each median, which is divided by the centroid. So each median, each of the 3 has this particular ratio. For example, if EM is, I don't know, X, that means MK is going to be 2 times that. There's a 2-to-1 ratio there. And if ML happens to be, I don't know, Y, that means MR is going to be twice that. And if MC is, well, I don't know, Z, that means MS is going to be twice that. And then they gave us a whole bunch of statements that we're trying to figure out, are they true, right? Are they true? Well, I went around one class today and they gave me each one one by one that wasn't true, and they left the one that was true. So let's look at each one. I think the first person raised their hand and said SM is equal to SK. Well, SMKM, sorry, number 4. Well, if you look at SM, that's 2Z, and if you look at KM, that's 2X. Unless they tell us that this is an equilateral triangle, those are not congruent. So that one is not true. Number 3 says that RM, RM, which is here a 2y, is equal to twice MC. Well, twice MC would be 2z. And once again, we have no knowledge based on the given information that the z's are equal to the y's. So that's not true either. So now we have these over here. So let's look at number 1. If you look at MC, which is z, and you multiply it by 3, you're going to get 3z. But when I look at SC, I see, oh, wait a sec. SC is going to be the sum of its parts. It's going to be 2z plus z, which is 3z. So this one actually is absolutely true. Because if you take one of the smaller parts, say that part, and you multiply it by 3, you're going to get the whole entire part. There you go. Let's see what other Regents questions I found before I end this video. Here it says, on a set of axes below, triangle DEF has vertices at the coordinates D, 1, -1, E, 3, 4, and F, 4, 2. And point G has the coordinates 3, 1. Owen claims the median from point E must go past point G. Is Owen correct? Explain why. Well, we haven't really gotten into coordinate geometry yet, but if we wanted to find the midpoint of DF, we would just add our 2 x's, which is 1 and 4, and you'd get 5, and then divide that by 2, which would be equal to 2.5. And we would add our y's, which is 2 plus -1, which is 1, and divide that by 2, and we get 0.5. That would be the midpoint. It would be 2.5. It would be somewhere right around here. And just by looking at DF, it's kind of obvious that G is not the midpoint of FD. So if we drew that right there, that would not be a median. So is Owen correct? He is not correct. No. And the explanation would be that G is not the midpoint of DF. Something like that would be fine in my book. The last thing I just want to show you, actually, that I found under Regents is that, I didn't even copy it, so I guess we will call it quits there. There you have it, everybody. Hope this was helpful.